Welcome to EDU World Space.
Okay, so this problem we're working with relative velocities. So in the problem it says a flat car is traveling to the right at a speed of 13 meters per second relative to an observer standing on the ground. So we know that the velocity of the flat car relative to the ground, which is v f slash g, is going to be 13.0 meters per second. Okay, and then in part A, it's saying that the scooter's velocity relative to the observer on the ground is going to be 18.0 meters per second. So that means v slash or vs slash g, which is the velocity of the scooter relative to the ground, is going to be 18.0 meters per second. And then B, it says it's 3.0 meters per second to the left. So then that means vs slash g for part B is going to be negative 3 meters per second because it's moving to the left now. So it's positive, it's moving to the right, and then negative, it's moving to the left. And then part C, it's saying that it's 0. So for C, we have 0 meters per second for the velocity of the scooter relative to the ground. Okay. And then for each part here, it's asking what is the velocity of the scooter relative to the flat car. Okay. So we have v s slash f for that. So we could write a simple formula to solve this then. So the velocity of the scooter relative to the flat car is going to be equal to the velocity of the scooter relative to the ground minus the velocity of the flat car relative to the ground. Okay. So we're taking the difference between these two velocities to get their relative velocity. So this is going to give us the relative velocity between the scooter and the flat car. Okay. So it's basically their velocity difference here. Okay. So let's do part A then. So for part A, we have the velocity of the scooter relative to the ground is 18.0 meters per second. And we know that the velocity of the flat car relative to the ground is going to be 13.0 meters per second. So part A, we just do 18 minus 13. So it's going to give us a positive 5 meters per second. Okay. So that means that so the magnitude is going to be 5 meters per second. And it's positive, so it's going to be going to the right. So the direction is to the right. Okay. And then part B, it's very similar. So for part B, we have the velocity of the scooter relative to the ground is negative 3 meters per second. And again, it's trying to the left now because it's negative. So we have to do negative 3 meters per second minus the velocity of the flat car relative to the ground, which is 13 meters per second. So we're doing negative 3 minus 13 using this formula here. So if we do that, we get the velocity of the scooter relative to the flat car is going to be negative 16 meters per second. So that means we have the magnitude of 16 meters per second. And now it's going to be to the left because it's negative. So the direction is going to be to the left. And then part C, we know that the velocity of the scooter relative to the ground for part C is going to be 0 meters per second. So we use the equation here. So we do 0 minus 13. So then we're going to get negative 13 meters per second. So that means it's the velocity of the scooter relative to the flat car, part C, is going to be 13 meters per second for the magnitude. And it's going to be going to the left because it's negative.